talked about that we can understand, we can now describe a sampling distribution, which could be extremely large. Like in the problem we're doing in class, trying to figure out the average names, there'd be 4.7 and 46 zeros elements in the sampling distribution. But we now know what the center, shape, spread, and shape will look like in the sampling distribution. And remember, our prediction, the one we're going on television with, is one of those. And we looked at those dartboards, and we want a dartboard that's unbiased. Okay? In other words, the mean of all of the means is going to be equal to the population mean. And we want a dartboard that's not very spread out. We want a dartboard that all of our guesses are right around the right answer. And we learned how we got that. If you take a larger sample size, all of those blue guys are going to get close together. We came up with a formula for it. And that's the formula for the spread of sampling distribution. All right, now we're going to go into some application problems. Okay, we're actually going to do some problems working with our sampling distribution. All right, this is the first deal, and it's a big deal. Before you do any problem using your sampling distribution, you're going to have to do what we call assumptions first. Okay, you're going to do about 100,000 of these things before the end of the year. You get really sick of assumptions. But before you do any problem that deals with the sampling distribution, you're going to have to do your assumptions first. All right, these are the assumptions. Now, there's only 3 of them right now. But eventually, we're going to get to about 6 or 7 assumptions. We're going to get to about 6 or 7 assumptions before we're done. Okay, assumption number 1. We're going to want to make sure that the sample that we took was done in a proper fashion, a simple random sample. Did you stand outside of basketball practice to get the heights of people? We want to make sure that we took a simple random sample. You guys picking those names out, good simple random sample. We're going to want to check it out. So the first thing that we're going to ask, you're going to draw this T-chart, you're going to write assumptions and check, and you're going to ask these questions. Question number 1, did you take a simple random sample? You're going to have one of 3 answers to that question. You hope that they did this. If they just tell you, hey, we took a good simple random sample, you just write the word stated, you're done. Or if they tell you, hey, we were standing outside a basketball practice and we were measuring the heights of students, you're going to say, no, you didn't have a simple random sample. And then you're going to tell me what's wrong with it. Convenience bias. Now, sometimes they don't tell you they did a sample random sample, and they don't even tell you how they did it. So in that situation, you're just going to say, okay, well, I'm going to assume you did a good job, and I'm going to move on. Okay, so really on this first assumption, you're going to have one of 3 answers. They're either going to tell you that they did a good job, you're going to tell them they did a bad job, or you're going to say, you didn't tell me anything, I'm just going to move on and say, pretend like you did a good job. I'm assuming you did a good job at that. Your second assumption. Remember I said we can only use that formula in certain situations? In other words, our sample size isn't too big. So the second assumption is going to be, hey, can we use this formula? Is this okay? Is this the right formula to use? So you're asking questions. Then over here, we're going to check it out. So just like you did with NP, N1 minus P, where you plugged in numbers, we're going to do that here too. You're going to make sure that your sample size wasn't too big. And then your last assumption, in order to draw that normal curve and do our work on our tables to find out the probability of stuff happening, okay, we're going to want to know if that sampling distribution, the distribution with all the different X bars, is in fact normal or not. And remember, the first thing that I told you is, this would be your reasoning over here, you write this out. You'd say, yeah, since the population distribution was stated as normal, in these problems you're going to do, they're going to tell you, hey, the population distribution is normal. So you're going to say, oh yeah, this is okay, since the population distribution was stated as normal, the sampling distribution is going to be normal. If we can get by all 3 of these, then we can solve a problem that has a sampling distribution. All right, let's do one. Let's do the one in the book. It's on page 517. Go to 517. doing example 9. They're trying to figure out the average height of women. Okay? And eventually they're going to take a sample of size 10 to try to figure out that height. All right, so it says that this distribution is going to be young women, and the variable x follows a normal distribution with a mean of 64.5 and a standard deviation of 2.5. Where's my bucket? Here's what that sentence says. This is the population distribution. This is the red distribution. They're telling us what the mean of all these are and what the standard deviation of all these are. Okay? Now in the real world, this is what we're going to try to predict later, but this is the problems that we're going to be working on now. So they're giving me the population values. Okay? So that's what those are. Find out the probability that if you pick someone, their height is going to be greater than 66.5. This is the problem you did back in chapter 3. Okay? They're just dealing with the bucket, the population distribution. So they're just in this thing. They want to know, hey, what are the chances? Hey, what percentage of these? What percentage of these are greater than 66.5? Well, they told us in the problem that the distribution, the population distribution was normal, so we can draw our curve, right? This is the problem you've done many times already. These are all young women. The population distribution. They told us the mean, and they want to know what's the probability of getting a height that's greater than 66.5. Shaded. That's what we're looking for. What do I do next? Z-score formula. So what is the Z-score formula for this? What do we got? Good. Isn't our old Z-score formula how many standard deviations away we are from the mean? Let's start plugging in some numbers. 66.5 minus 64.5. Did they give us the population standard deviation number? They sure did. 2.5, is that right? So what does that z-score come out to be? Somebody throw that in your calculator for me. 0.8? Yeah, 0.8. So I still got some of you losing points on your test because you're not taking it over to your picture. When is that going to stop? Please make it stop. Okay, go fill out your picture. And then I still have some of you out there giving me the wrong percentage here. Go look this up. What's the percentage of the shaded region? Go to your green sheets. What's that going to be? Come on, look at my picture. Is that 78% of the picture? No, and I still got some of you doing this. Don't we have one more step to figure out the percentage of the shaded region? 1 minus that, right. And so what is that, point 2 what?
0.2.
I got 2 different answers. 0.80. That's right.
Yeah.
Then we write up our sentence. You know what? 21.19% of these heights are greater than 66.5. Okay, so far it's a problem we've done a million times. Now on these problems that you're going to be doing tonight and tomorrow, it's going to be hard to figure out which distribution we're talking about. Now, we're going to move over to the next part of this problem. They're now going to go find a simple random sample of 10 heights and go find the mean of those 10 heights. And now they want to know the probability that the mean of those 10 heights is greater than 66.5. So we're not here anymore. We're not in the population distribution. I'm trying to figure out what percentage of these guys are more than 66.5. Now remember, these guys are way more bunched up than these were. Remember, weren't your individual names you got? Did you get some like there were 5 and 20 and whatever, but then you found the mean of them, they all got kind of bunched up here in the middle? Okay. So the second part is when I go take a random sample and I go find a mean, they're working off of this distribution. Okay, so before I can do any work on the sampling distribution, we must go through our assumptions. Okay, I don't know if I can use that formula yet. I don't know if I can draw a normal curve yet. So that's exactly what we're going to do. So the first thing that you're going to do, since we're in the sampling distribution, is we're going to go through our assumptions. Draw your T-chart. And what's assumption number 1? We want to make sure that we drew a simple random sample of 10 girls. So, do we have a simple random sample? Question mark? What do we got on this? What do you think? Yeah, in this case it was stated. Yeah, they're telling us we did a good job. I don't know if we picked out of a hat or what we did, but they're telling you we did a good job. So we just say stated here and check mark. That one's okay. All right, assumption number 2. I just gave you that new fancy formula. Can we use it? That's what we're asking here. So assumption number 2 is the standard deviation formula equal to the standard deviation of the population over the square root of n? Question. Number 2, well, it is if our sample size is less than or equal to 10% of the population size, capital N. And now let's plug in the numbers. What was our sample size in this problem? 10. Is 10 less than or equal to 10% of, now, whoa, do we know how many young women there are in the world? We don't, right? So we would just say all young women. And is that pretty safe to put a check mark there? That 10 is going to be less than 10% of all women? Sure. And then finally, number 3. Will our sampling distribution, is the sampling distribution of the X bars normal? And how would we answer this one? Is the sampling distribution, are all those blue numbers going to constitute a normal distribution? How do you know? Yeah, didn't it tell us that the population distribution was normal? So we write that. Yes. And then, you know, since population distribution is stated normal, the sampling distribution is normal. Check. Okay. So because of number 3, I can now draw that normal curve. Now remember, these are all of the possible sample means. These were all the women's heights. These are the mean of all women of sample size 10. What is going to be the center of that distribution? What is it? How do you know this is 64.5? Right, look up at our sampling distribution back there. Isn't the mean of all of the possible sample means going to be equal to the population mean? Isn't that always going to be the case? Now, was it the case, this is kind of critical here, was it the case, if I found the mean of all those blue guys, is that for sure going to be the mean of that bucket? I would need all the X bars, right? That one we got in class is probably pretty close, but it's not, right? I need all the X bars, okay? But that's what we have here. This is the sampling distribution of all the possible X bars. All right? So I want to find out the probability that my sample mean is greater than 66.5. right, now things get interesting. What is our z-score formula going to look like now? It changes a little bit. What's it going to look like? Let's think this through. Last period got this. It was pretty impressive. So,
X-bar.
stop! Perfect. Aren't we trying to see, aren't these all sample means? So we're trying to see if our mean is greater than 66.5. Minus, you're on fire,
The mean of X-bar.
mean of x bar. You can just write, isn't that the same thing as the mean? You could write mean of x bar here. You can just write mean. It's the same thing, right?
Yeah, divided.
Right? And then divided by,
Standard deviation of X-bar.
yeah, but can we go a little further than that? What's the, we want the standard deviation of this distribution. What is the standard deviation of this distribution?
Standard deviation of over the square root.
Right? This is the sampling distribution. Now these are all x bars. I want to see if my x bar is greater than the mean, and that's the standard deviation of this distribution. All right, let's plug in the numbers. So I want to see if 66.5 minus 64.5 divided by, that's the standard deviation of the population. That's 2.5 divided by the square root of 10 in this problem. The sample size was 10. Go see if you can get your calculator to find out that z-score. You use parentheses or whatever tricks you want to use. We all need to get the same z-score out of that. If you're not using your parentheses right or whatever, you might get some crazy number. What do we get? 2.53 is correct. If you didn't get 2.53, you're just not using parentheses right or something. So it turns out, aren't all those x bars a lot more bunched together than the original heights would be? Weren't all those blue means that we got of size 20, weren't those way more bunched together than the original length of names were? So it turns out if you take a sample size of 10, it's way less likely you're going to get a mean of 10 girls to be greater than 66.5 if the real mean is 64.5. What does that come out to? It's like 0.00 something. 57. Almost impossible. Almost impossible to get a sample mean of 10 girls. Especially if you took a good simple random sample, right? If I'm standing outside of basketball practice, I'm probably going to get that. But there's not many samples out there. Only less than half, around half of 1% of the samples out there would give you a mean greater than 66.5. Okay? Okay, just threw a lot at you. Questions, comments? And that's what some of your problems you're going to be doing. They're going to give you the population distribution information. You're going to go get that information. And then they're going to say, hey, now I'm going to take a sample of something. Boom. Your mind goes right to sampling distribution. Now I'm looking at all the different x bars I can get. What are the chances my x bar is a certain? Okay? Okay, remember, whenever you're going to do a problem dealing with the sampling distribution, make sure you do assumptions first. Make sure you label your picture well, and of course do a nice write-up.